Okay, so now we're going to continue on with the 1.1 notes with section 1.1.2 dealing with the power to a power property. So first set of examples says expand the expression and rewrite using exponents. Use the results to determine a rule for raising a power to a power. Okay, so we talked about yesterday how, again, when you are evaluating these exponential expressions, it's important to not only recognize what the exponent is, but what the base is. Okay, so here the exponent is obviously the 3, but the base of that exponent is a squared, right? So we kind of see two exponents there, so we got to be careful. Right now we want to evaluate using this exponent, the 3 as an exponent, and this a squared as a base. All right, so again, we talked about yesterday that, right, what an exponent does, it tells you, right, how many times you're going to multiply the base times itself. So we're going to take this base of a squared, and we are going to multiply it. Let me do that a little bit better here. And take that base of a squared, and then we're going to multiply it times itself 3 times, right? And that's what the exponent of 3 is telling us, to take this base of a squared and multiply it times itself 3 times. All right, so now we're going to reassess what we have here. So we want to think back to what we learned yesterday, is that when we are multiplying these exponential expressions, and we notice that they have the same base, we know that our answer is going to have that same base. And what we're going to do to the exponents is add, right? So it's going to be 2 plus 2 plus 2, which is 6. All right, so we got a to the 6th. Part B, so we got this exponent of 4 that's attached to this base of a cubed. So again, that's telling us we're going to take that base which is, as a repeating factor. We're going to take that base as a repeating factor, so a to the 3rd. We're going to multiply times itself 4 times. All right, so again, that exponent of 4 tells us we're going to take a to the 3rd and multiply times itself 4 times. So again, using that rule, that product to a power rule, right? Because they all have the same base, we're going to keep that base as our answer for our answer, and we're going to add the exponent. So 3 plus 3 plus 3 plus 3 gives us 12. All right, one more time with part C. We got a to the 5th squared. Okay, so that exponent of 2 is saying we're going to take a to the 5th and multiply it times itself twice. We're going to use that product to a power rule, saying we're going to keep the base and then we're going to add the exponents. All right, so I want you to take a moment to think about how can we shortcut this, right? How can we take a look at our original problem here, and how can we kind of shortcut it to get us to our final answer? Is there a way? Okay. All right, so here we're going to establish a rule. So if we have an exponent attached to an exponential expression, right? So again, we see 2 exponents here, right? An exponent attached to an exponential expression, right? We're going to keep that base and we are going to multiply the exponents. Right, so you see that how that works from our original 3 problems, right? Using this rule, we're going to keep this base of a for our answer, and then we're going to multiply the 2 exponents. 2 times 3 is 6. Keep the base of a, multiply 3 times 4 is 12. All right, again, when we're putting an exponent to an exponential expression, we're going to keep that base, and we're going to multiply the exponents. All right, so let's see what you can do with this next example right here. Okay, so again, we follow the rule. We're going to keep the base, and we're going to multiply the exponents. 10 times 12 is 120. All right, so let's see if we can apply a couple of those rules that we just learned over the last day and a half with these examples. Okay, so we want to simplify, so we want to multiply here. All right, so what I'm going to do is, because this is all multiplication, right? We don't see any plus signs or minus signs because this is all multiplication, right? I'm going to do a little rearrange, right? I'm going to use that commutative property of multiplication that says I can rearrange. Okay? And you might want to consider doing this now, right? So until you get the hang of it. So I'm going to put this coefficient of 3 and this coefficient of 2. I'm going to multiply those together. I'm going to take this x to the 4th and this x to the 5th, and I'm going to put those together. All right, again, the commutative property of multiplication allows me to go ahead and rearrange these factors of multiplication in any order that I want. So that's going to allow me to more easily see, hey, with the 3 and the 2, I'm going to go ahead and multiply those to get 6. Here we're going to apply that rule. We're multiplying the same base. We're going to keep the base, and we are going to add the exponents. All right. I'm going to skip over the part C. All right, so here we have something a little different. All right, we have this exponent of 2 hanging around. All right, this big base right here of 4x cubed y to the 5th. Okay, so again, being able to remember to do some of these little things to help you with these type of problems. So what I'm going to do for this one, I'm going to take that exponent of 2. I'm going to kind of distribute it to everything that's inside the parentheses. So that 4 is going to get an exponent of 2. That x cubed is going to get an exponent of 2. And that y to the 5th is going to get an exponent of 2. Right? Can you kind of hopefully remember that concept of the distributive property when you had parentheses and a number hanging around the parentheses back in junior high? So we're kind of using that idea a little bit. Say we're going to take that exponent of 2 hanging around inside the parentheses, and we're going to distribute it to every factor that's inside the parentheses. Okay, so then that's going to allow us to, again, be able to multiply or use a rule, right, in a more efficient way. 4 squared is 16. Here we have that power to a power rule, right, exponent to exponent, so we're going to keep the base and we're going to multiply the exponents. Power to power, exponent and exponent, we're going to keep the base and we're going to multiply the exponent. All right, so let me give you a few minutes to see what you can do with part B and part D. All right, so let's take a look. So here we have a problem similar to part A. We're going to do a little rearranging. Right, I'm going to take that -5 and that 4. I'm going to multiply them together. I'm going to take that a cubed and that a to the 6th and multiply those together. And then I'm going to take that b squared and that b to the 1st and multiply those together. All right, so again, doing a little rearranging so that I can see what I'm actually going to multiply and where I'm going to use an exponent rule. Keep the base, add the exponents. Keep the base, add the exponents. All right, so for part D, again, we have an exponent hanging around outside of parentheses. Again, got to be aware of those things. So we're going to do like what we did part C. We're going to go and distribute that. So it's going to be a 5 squared, x squared, and y cubed squared. All right, everything in that parentheses is going to get that exponent of 2. The next example, we're going to distribute that 3. So that 2 is going to get an exponent of 3. X squared, exponent of 3. And that y to the 4th, an exponent of 3. All right, so then we're going to take a breath and then look to do some work. 5 squared is 25. X squared, power to a power. Keep the base, multiply the exponents. This is 2 cubed. 2 times 2 times 2 is 8. Power to a power, keep the base, multiply the exponents. Keep the base, multiply the exponents. Once again, I have all this and I need to simplify. So I'm going to do a little rearranging. I'm going to put the 25 times the 8 next to each other. I'm going to put the x's next to each other and the y's. 25 times 8 is 200. X squared times x to the 6. You keep the base and you add the exponents. Keep the base, add the exponents. Okay, so with this last few examples, right, we're going to try to put it all together again. Here we're going to rewrite the expression using the rules of exponents and then evaluate it in two different ways. Okay, so here we have 2 cubed squared. Okay, so a couple different ways that we can evaluate this is that we can rewrite it as 2 cubed times 2 cubed, right? And that's what it means to square something. We're going to multiply it times itself. That's the base. And then we look at it and say, okay, let's keep the base, right? Same base, going to keep the base. Now we got to be careful, right? This is different than what we saw before where they were x's, right? The common mistake here is that someone would multiply 2 times 2 to get 4. Okay, so again, let's remember our rules. If we're going to apply those exponent rules, know that the base should never change. So 2 cubed times 2 cubed, we're going to keep the base the same, and we're going to add the exponents. Okay, so again, when we evaluate that, that's going to give us 64. All right, again, another way we can evaluate this is, again, if we do our power to a power rule, hey, I can just multiply those exponents. And again, that will give us also 64. All right, part B, a couple ways we can do this. We can just go ahead and expand. 5 squared is 5 times 5. 4 squared is 4 times 4. Do the multiplication and we get 400. Or we can rewrite this. Say, all right, let's do that reverse distributive property. All right, I'm going to go ahead and put those bases together in one parentheses, bring out the 2 as an exponent. So now I have 5 times 4 in parentheses, which is 20. Then 20 squared is also 400. Okay, so we want to work backwards here. We want to rewrite each term as a different term raised to a common power. Okay, so again, trying to work backwards from some of the properties that we learned here. Again, because we notice that both the x and the y have that exponent of 2. Right, we could kind of do the reverse of the distributive property. Let me go ahead and put the x and y in the parentheses as a base. And we have the exponent of 2. Here with this one, again, it's going to take a little work for us to kind of see these, right? But notice that these exponents right here, 3 and 6, right, they have a common factor of 3. So what I'm going to do is I'm going to prepare myself. So, okay, let me see if I can take out an exponent of 3. So let's start with a y. So that's going to give me y squared here, right? Again, if we did the power to power rule, 2 times 2 would give me 6. X would be just a 1. Again, if I did exponent to a power, multiply, that would give me the 3. What would go here right where the 8 was? What do you think? All right, so if you said 2, you're right? Because 2 cubed would give us 8. All right, so that's it for today's lesson. All right, go ahead and finish up the 1-1 homework worksheet and then submit that on Canvas. If you have any questions, let me know.